working on making petri dishes that act like the human body. This is important for cancer research because cancer treatments are tested on human cells in environments like petri dishes long before they're tested on people. As you can imagine, the conditions that cells experience in a petri dish are quite different from those in the body. While petri dishes are a simple system, the body is a complex system with many different types of cells and many chemicals that can affect them. Because this environment around the cells has a huge impact on their behavior and their response to the treatment, a drug that works in the dish might not work in the body, or vice versa. This leads to many potential treatments being thrown out once they're tested on people, and after significant time and money have already been invested in them. I'm hoping to help solve this problem by using engineering to create better devices for testing cancer treatments that more accurately replicate conditions in the human body. My research focuses on the control of one very important chemical in the environment around the cells: oxygen. I've chosen oxygen because it's an important parameter in the outcome of many types of cancer. Tumors with low levels of oxygen tend to be more aggressive, more likely to spread, and less responsive to many treatments. Now, in many of the tissues in our bodies, the oxygen levels are highest, closest to the capillaries, and then they drop off with distance from the blood vessel, forming a gradient within the tissue. In my device, which you can see on the inside of my slide, I'm mimicking a small block of tissue near a capillary, complete with this oxygen gradient. To do this, I use micro-scale channels, about the same size as a human hair or a blood vessel, that hold fluid and cells and control their flows. These channels allow me to precisely control the oxygen levels in the environment around the cells. And in the first part of my research, I determined that the channels can produce the types of oxygen gradients found in tumors. My whole device is smaller than the size of a postage stamp, and it integrates tiny sensors into the tiny channels to measure the exact level of oxygen around each cell. Over the next few years of my PhD, I'll be working on improving the control and measurement of oxygen in my device, as well as using it to help cancer researchers determine the role that oxygen plays in the effectiveness of cancer treatments. It's my hope that my project will help expedite the development of new, effective cancer treatments, as well as work towards mimicking the body as a whole in a petri dish. Thank you.